In this video, we are going to talk about how to graph intercept form of a quadratic function. So intercept form is going to look like y equals, and it's actually, sometimes it's called intercept form, sometimes it's called factored form because it is the factored form of the parabola. So it's going to look like this, where p comma 0 and q comma 0 are our x intercepts. So if I look at this first example, it says x minus 2 and x plus 3. That means my x-intercepts are positive 2 and negative 3. This next example, my x-intercepts would be negative 5 and negative 6. And this last example, my x-intercepts would be 9 and 1. So since we know how to find the x-intercepts from intercept form or factored form, we can use this to help us graph a quadratic equation in intercept form. So I can see my two x-intercepts are 2 and negative 4. That's always going to be opposite of these. So I'm going to plot my points at positive 2 and at negative 4. Now to find the axis of symmetry, we're going to average the x-intercepts. So I'm going to add them together and divide by 2. And I'm going to get negative 1. So this is where my axis of symmetry is going to be at x equals negative 1. Now I could have also said what's halfway between 2 and negative 4. So 2 and negative 4 are 6 units apart, so 3 would be halfway between, and 3 away from each of those is at negative 1. So I could have also found the midpoint between negative 4 and 2. So my axis of symmetry is always the same as the x of my vertex. Then I'm going to take the x of my vertex and I'm going to plug it back into the original equation to solve for the y of the vertex. And again, we could just plug this whole thing into your calculator, but I'm going to do it in steps. We're going to get negative 9. So I'm going to plot my vertex at negative 1, negative 9, which will be right here. I'm also going to take that vertex and put it in the middle of my table. I'm going to put two numbers that are smaller above and two numbers that are bigger below. Then I'm going to have to plug in each of those values into my equation to find the y value. So I'm going to plug in negative 3 first, and I'll get negative 5 times 1, so negative 5. Then instead of negative 3, I'm going to plug in negative 2. So I'll get negative 4 times 2, which is negative 8. Then I need to plug in 0. And I'll get negative 2 times 4 is negative 8. Then the last number I'm going to plug in is 1. And I'm going to get negative 1 times 3, so negative 1 times 5, so negative 5. So I'm going to plot the points that I haven't plotted yet. So negative 3, negative 5, negative 2, negative 8, and then 0, negative 8, and 1, negative 5. And then I'm going to connect my points. Now let's do the same thing for the graph of number 2. So my x-intercepts are going to be positive 3 and negative 1. This negative in front does not affect the x-intercepts. It just tells me my graph is going to open down. But still opposite. So positive 3 and negative 1. And again, to find the axis of symmetry, I'm going to average my x-intercepts. And so I get my axis of symmetry is at 1, or I could find the halfway point between my x-intercepts, which would also be at 1. Then my axis of symmetry is always the same as the x of my vertex. So I can take that x and plug it in I'm going to get negative negative 2 times 2, so that'll give me positive 4. So plot my vertex of 1, 4 at 1, 4. I'm going to take that vertex, put it in the middle of my table, and then put 2 numbers smaller and 2 numbers bigger, and then I'm going to have to plug each of those in. So negative, negative 1 minus 3, negative 1 plus 1, and that will give me 0. Do the same thing except for instead of negative 1, I'm going to plug in 0. Now we get negative 3 times 1, so negative 3. Then do the same thing but plug in 2. I'm going to get negative 3. And then do the same thing but plug in 3. And I would get 0. So I'm going to plot those remaining points. So negative 1, 0, I already have. 0, negative 3. Oh, sorry guys, these should have been positive 3. Positive 3. 2, positive 3. So then my parabola is going to look like this. All right, so now we're going to change this to standard form. So what does that mean? That means I want it to equal ax squared plus bx plus c. So that means I need to multiply this out. So first I'm going to do the first guy, x times x, and then it'll get me x squared. Then I'm going to do x times negative 3 to get negative 3x. Then I'm going to do 6 times x to get 6x, and 6 times negative 3 to get negative 18. Then I can combine these two like terms in the middle, so negative 3 plus 6 would give me positive 3. So my standard form would be x squared plus 3x minus 18. And so the y-intercept is when we plug in 0 for x. So if I were to plug in 0 for x into the equation I just found, I would get that y is negative 18. And if you notice, this number is the same as this number. We'll talk about this a little bit more tomorrow, but our c value is always going to equal our y-intercept. So let's test this out. Let's try number 4. So again, I'm going to multiply this out. So x times x is x squared. X times negative 4 is negative 4x. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. Combine negative 4 and negative 2, so I get negative 6x plus 8. Now again, if I plugged in 0, I would get that my y-intercept is 8. And if you notice, that matches the c value again in standard form. All right, now let's do some interpreting. So they want us to write the equation in intercept form. So I can see that my x-intercepts are at negative 6 and negative 2. So that means my intercept form would be positive 6, positive 2, because again, it's always opposite. The domain would be negative infinity to infinity, because this arrow is pointing left to negative infinity. This arrow is pointing right to negative infinity, or positive infinity, excuse me. Again, this is always true for parabolas. My range is at negative 4, so it'd be negative 4 to infinity. Now they want me to circle where it's increasing. So if I read a graph from left to right, it's decreasing, then increasing, increasing here, and decreasing here. So squiggle where the graph is decreasing. When x is negative 2, what is y? Well, x is negative 2 is right here. If it's on the axis, then y equals 0.